Before we get into the internals of the TLS protocol, let's look at how TLS is used from Java. Right now, I do not use TLS. This is the TCP server that we had before, where it waits for any connections on TCP. It'll read up to 5 bytes and print what it receives. And then we have our old TCP client as well that's sending the 3 bytes 10, 20, 30. So when I run the client, it sends 10, 20, 30, and we see from the server that it did hear from localhost those 3 bytes. We can also see, if we look in Wireshark, for things involving TCP port 5679, that we have the TCP connection here, the SYN, the SYNAC, and so on. And eventually we see some data right here, which is 10, 20, 30 sent, of course, in plain text, so we can see it, because that was what was sent over the TCP connection. If I go back to my code, where I have the server running, and this time I'm going to use an SSL client. For SSL, we do not create the socket directly, but we use an SSL socket factory. And before we use that SSL socket factory, we set some properties that have to do with how we want to configure the SSL connection. So here we are using client key store, which is setting up some keys that the client should use, as well as the certificate chains for what it will trust from the server. If I run this SSL client while our TCP server is running, it will connect, but then it will produce an error, remote host terminated the handshake. That's referring to the SSL or TLS handshake. If we go over to the server, we see that it heard from localhost, but it got these arbitrary looking bytes. That turns out to be the beginning of the TLS protocol. Let's stop this plain TCP server and instead pull up an SSL server. So SSL or TLS server, much like the client, it uses a SSL server socket factory. So another factory where we set some properties before we started out, and these properties set up the server key store, which is the server keys and the certificate chains of clients that it'll recognize. Otherwise, it looks the same as our TCP server, which is the point of this SSL or TLS layer. When we run it, and this time when we go back, if we run the TCP client, then the TCP client gets stuck, and that's because the server was waiting to connect to it. And now we've broken our server because it's not set up to handle errors of broken clients. So let's try it again. This time, get rid of the TCP client, go back to the TLS or SSL client, and connect. And we see now our client sends the bytes 10, 20, 30, and the server over here received the bytes 10, 20, 30. This is all still over TCP and over port 5679. So if we go back to Wireshark, we can look again for our data. You see now in Wireshark's recording there are all these TLS v1.3 messages. And you see things like client hello that are part of the protocol, and change cipher spec, which is part of the protocol, and application data, which is where we sent the data, but we won't be able to find the bytes 10, 20, 30 here. It's been encrypted and made much longer, and so we can't see what's going on between the SSL client and server.